Well, hi, good morning. Thank you for joining me in my shop here on, guess what? September 1st. Oh my gosh. Summer's coming to an end. It's another cool day here, but the weather, people are promising a shift to hot, hot weather in just a couple days. So I best enjoy the coolness while I can. Now, what are we going to do with this radio here? So I think what I'd like to do is pick on a capacitor that I believe will be critical in the radio's operation. Remove it in order to replace it. I'm pointing at the one I think is most likely the guy. Look, it's going right to the chassis here. And what I've... Oh, there's another to the chassis. Okay, that's a little odd. With lots of things hooked up to the chassis in this radio. This capacitor is going down to the chassis. This terminal strip is soldered very carefully to the chassis, but there's nothing hooked up to the ground point here. I wonder why they would worry so much about soldering that. How about some other connections? Yeah, there's another connection down to the chassis here. Now that could be a pin 1. Let's just do a little where I can see a pin 1. Yeah, so there's a pin 1 and it's soldered right to the chassis, and it's not a metal tube. It's so here's another one. This one's soldered right to the chassis, but there's no pin from the tube here. And this one's soldered to the chassis. I can't see which one's pin 1, but I'll bet you that's pin 1. What about this guy? Nothing on the chassis there. Well, the great thing is, thank you, Rory, for sending me the schematic for this radio. Fantastic. I'm going to avail myself of it right now, and I believe there's a write-up that's come with it too. So let's take a look at that, and maybe we'll find out what's going on with this. It's a point 2. It's a big capacitor right to the chassis there. Let's check out the schematic. See what we can find out. Okay, and here it is. Now, this one's labeled a Crosley 1240. My radio is labeled Mohawk 1240, but these are the right tubes, and I'm pretty sure this is going to be the correct schematic. The tube part layout all matches. Everything seems to match. Even this note: 1400 kilocycle RF trimmer below chassis on coil, and there is one under the chassis. So, okay, we can go with the assumption, safe assumption, this is the correct schematic. I'm just looking at these capacitors I changed. 30 at 150, so at 80 at 150. I put 50s in here, which seems to be okay. And then the bypass, no, there was no bypass. There's a third electrolytic capacitor. Where's that? A, so there should be another A. Well, we'll find it as we there. Oh. A, 25 volts here. Oh, right, here's the output tube. I was thinking this was, but they've put the rectifier here. So here's the output tube. There it is. Very good. 140. I measured this at 175, I think, and it looks like it should be a 170 based on the color pattern. Okay, that's fine, though. I don't think there's a problem there. So let's just go back here, take a look at a few things. So we have an antenna coil with a wire out the back, capacitor. This transformer is in the radio chassis, on the radio chassis. Let's go to the grid here. Grid oscillator, grid. Ooh, let's just zoom in a little bit. Oh, there we are. There's the grid connection up there. Grid cap. leading its way over to the antenna. Here's the antenna trimmer. This is right on the back of the radio, right on the antenna itself. The tuning capacitor with its trimmer. And this is the oscillator coil with its trimmer, and then it comments there's another one. Where is it on the schematic here? 14 loop, RF loop trimmer, loop. Isn't that this? Oh, this is showing the physical location of the trimmers. That's why this note is here. So, somewhere in here is this other trimmer that's underneath. Unless it's this, I don't think so. Well, we won't worry about it right now. We can worry about it down the road. Don't need to figure everything out. Look at the size of this resistor. 11 megohms. Wow. Usually that's a 2.2, something like that. 11. Wow, they were feeling crazy that day in the design office when they did that. 50, the M means K on this schematic, so 50K resistor there. Okay, let's look for that big capacitor. Now that big capacitor was a 0.2. Maybe we can find it if we pick a shield, or I'm sorry, a screen. Well, that does say shield. Suppressor screen. We follow the screen around. Maybe we'll find that big capacitor. That's what I'm thinking. 0.03. Hey, what's going right off the side here? We don't have the whole capacitor on to the speaker. I did not find it. I did not find the big capacitor. Well, another thing is, let's look at the grounding in here. So I don't see any chassis symbols anywhere, like any ground symbols anywhere. So this must be the chassis, this outside box that they've drawn, and look at all the connections made to it, all kinds of them. One of these connections is going to lead back to that big honkin' capacitor. Where? There it is, 0.2. There it is. So it's and so what is this line right here? This is probably, oh look, it's hooked up to the cathodes. So this is B minus here. B minus. Chassis ground, they wrote it right there. Whoops, I didn't have to think about it. Chassis. That's the North American use of the term ground, so abusive. And then we would find the B plus. This line here is the B plus. And then, excuse me, look to the couple of rectifiers here, or diodes rather, and this will be, and the 11 meg resistor is the giveaway. This is the AVC line coming back. Kind of weird how they drew that. It would look like this coil is shorted by this wire. I think maybe this dot shouldn't be there. This one here. Okay, and then it's going to make its way to the grid, going around the coil here and all that. Yep. And here it's making its way to the grid through there. Okay, so we know what the 0.2 is. The 0.2 is its job is to quiet down the screen supply. Whoops. This way. Screen. Wait a minute here. Well, I'll take that back. I got this all turned around. This is the shield coming out to the chassis. So this is connected here between the chassis and cathode. This is a little different than what I'm usually find in these radios here. Maybe I'm... So this is between the B minus and the chassis. Let's take a look at the power supply, just see how they've done things here. So incoming AC, double pole switch. That's a little unusual in these radios, but for sure, with this one, when you turn this radio off, the radio is off, it's dead. Other radios, watch out, these unpolarized plugs can go in the outlet either way, and even with the switch off, you can have 120 volts all over the radio inside. No current flowing, just there, waiting. So let's follow this line. Start of the heaters. Oops. Let's follow the other line. Bottom of the volume control. This is the B minus. Let's take a closer look at what's going on, because the B minus appears to not be the chassis. The B minus is this wire. And the chassis is being drained into the B minus line through this. Oops. And this goes to the shield. Whoops, I keep clicking my shield. So they're showing the key for the tubes, and you can count these 1, 2, 3, 4, 5, etc. They've shown all these with the keys straight up. Oh, just one here to trick you. Almost all of them keys straight. I'm just making observations here that'll be helpful. General observations that'll be helpful down the way. Power supply, positive feed. You have the less filtered, I got this right, the more filtered, less filtered, usually the less filtered. Oh, I'm all turned around. I am turned around here. What's going on here? So this side is connected to the cathode. The plate, I can't reason this out in my head. What is happening? I don't need to reason out. The great thing about us human beings is we're able to move forward without knowing fully what we're doing. We don't get paralyzed from a lack of information. We are compelled to move forward, and that involves taking risks. We are risk takers. Okay, enough philosophy. Well, so what would happen if I, for instance, decided to remove this capacitor? I'm going to replace it. Let's say I'm going to replace it. Why would I even do that? It's not really a critical. If it's doing its job as it is, a leak is not that important here. Maybe I take that back. I'm gonna stop for a bit because I sort of overwhelmed myself here. I got my head going in too many directions at once. So I'm gonna have a little coffee break and sort of clear my head on this a little bit. Good idea. Okay, a little bit of coffee, settle me down here. Let's stay focused on the screen as a start, the screen circuit. So we'll pick this tube, and there's the screen connection, and sure enough, there's the capacitor there. And it's going to the B minus line here. So this guy's job is just the 0.05, is to decouple, drain out, get rid of round away any signal that might be present. And see what they've done, they've hooked the capacitor right to this tube, and then they've got this sort of moderate sized resistor sitting here, and that sort of forces the filtering action. Kind of think of it that way, kind of. Okay, now is there anything else hooked up to the screen in terms of a capacitor, a decoupling type capacitor? Well, you're connected through here. So this has some effect, for sure, on the screen line. Apparently, these electrolytic capacitors aren't so good at the higher frequencies. And that's why you would need this guy. This guy, he could be sitting right here. You could draw him in right here, just in parallel with this. Am I right? Am I right about that? Right from here, right up to here? I think I'm right. That's all that matters. Okay, any other capacitor along? Well, here's one right here. A similar size capacitor. And it's connected between the screen and the plate of the output tube. And I believe its job is to stop oscillations from developing here, and also kill any RF that's made it all the way through the radio and is coming out of the amplifier tube here. Am I correct in that? Gee, I don't know. Yeah, sounds good to me also, so I'm going to leave it at that. So I think these two capacitors, this one in particular, is of interest. If this capacitor were, let's say, open circuited, and the capacitor itself had failed, this radio would probably howl a lot. Now where can I find this capacitor? I guess I can look right at the pin on this tube and I'll find it. It's going to be right close. I'll also look for this 30K resistor. So screen of the 12A8, look for a 0.05. That's the guy we're going to focus on today. Maybe this guy too. Let's do this one first. 0.05. Okay. Which tube is which? So the this one is the tube of interest. And I can't see. I'm looking for the key on the tube so I can count the pins. It's just hidden from view here. There it is. This is pin number 1 right here. Okay, if that's pin 1, I didn't count the pins on the schematic, did I? Yeah, you know what? Pin 1 is soldered down, so that proves that's pin 1. Okay, pin 1, 2, 3, 4. So I see a wax capacitor on pin number 4. Is that the capacitor we're after? I think it kind of has to be. So we count the pins. We go 1, 2, 3, 4, and there it is. There he is. That's the guy right there for sure. Okay, we're going to nip them out. We're going to test them. And then we're going to try running this radio without this capacitor in place at all. This is some idea I got the other day, as in yesterday, or maybe the day before. Something I could be doing to further explore the operation of the radio and learn more from it as I'm doing it. So we would be imitating the idea that this capacitor's gone open. We'll find out the hard way, sort of the hard way, in a sense. Wow, this is really tight down in here. I want to leave a little bit of wire on the capacitor so I can test it. There we are. Clip lead it so I don't forget where it came from. or let's just say reduces the odds that I'll forget. Okay. Here he is. I just put a hole in the speaker. Came really close to doing that. No. Wow, I just about jabbed the pliers right through the speaker. Should be a 0.05. There he is. 0.05. 400 volts. Let's put him to the test. Now, in this circuit, if this were leaky a bit, I have the feeling it wouldn't really matter much. But a loss of capacity would be, I think, well, we're going to find out when we do the experiment. Complete loss of capacity. There. Okay, let me see if I can cast a bit of a shadow here. There we are. Okay, 50 volts. What do you say? Okay, so it's opened halfway. And it's not going to open on 150, halfway. So, again, as far as capacitors go in these old radios, this is typical. In some positions, this would be a problem for sure. Excuse me. Whether it's really a big deal in this position, you know, to have a little bit of a leak in it. Now I got this clip lead here, but I want to remove the clip lead because I want to do this experiment. So what I'm going to do, what am I going to do? I'm going to stop just for a second here. Okay, so what I'm going to do is I'm going to photograph this. Yes, it's on video, but you know, it's a hassle to get through video. This is a good shot here. Good chunk. There we are. Okay, now I can remove the clip leads. Yeah, if that clip lead was in place and we operated the radio, I'm sure we'd have an exciting time in here. Okay, we should step back a little bit. Volume's at minimum. Plugged in. So what do I expect to have happen? I expect there'll be a lot of oscillations due to feedback through the IF. I expect when I tune the radio, their pitch and quality will change a lot. I expect them to be loud and overwhelm the radio. So you have no hope of tuning anything in. It's going to become a weird warbling thing. Well, I don't know now, because I'm thinking, geez, that's kind of what would happen if you took capacitors off the AVC. But this is off of the screen. Anything bad happen? Well, only embarrassment, I think, is the only bad thing. Here we go. Today's power is 109, 112. First, you know, there's a big power draw, so the voltage drops because I've got these light bulbs in the circuit over here. 116. Sounds completely normal. Sounds better than ever. Well, is this some kind of joke? Ah, you didn't need that capacitor. My God, somebody's got to go tell all the engineers there's a capacitor in these radios and not needed. Okay, well, I think at the last minute there, when I said to myself, hey, I'm thinking about the AVC line and removing capacitors from that, and that would give all that wild feedback and craziness. Removing the decoupling capacitor from the screen appears to have had no effect, no impact on the radio. Well, the next thing would be to put one in, solder one end, have the other end close, and then click it in and out. See what happens there. Power off. Wow, I'm a little bit, you'd think, oh, come on, you remove a part, surely the radio can't work after that. It's going to do some weird behavior that something's going to happen, and you're not going to be happy. But hey, let's not put that. You see, this goes to show what I've known all my life. In fact, when I was working at my job, very early on in my job at the power company, I realized that I could distinguish myself by bringing information in that nobody else had. And how would I do that? Read some books, because nobody else was reading books. And the other one was make field observations nobody else was making. Go places nobody else was going. Look at things no one else was looking. Put meters on things no one else was putting meters on. And make discoveries nobody else was making, even though they were there for anybody who wanted to take the time. That's how I played my career at the power company, and I was highly successful from that simple principle of being the guy in the meeting who's always got some interesting information that nobody else has that is important. That's important to know. Yeah, it can't just be any old information. It's got to be important stuff. Anyway, more proof of that being true. Here, you don't need that capacitor. Now we all know it. More coffee. Coffee worked. Well, let's take a look in my favorite book. I have many books on radio repair. Most of them go over the same, somewhat shallow territory. It's a deep topic, so you got to go a long ways to get down to the bottom. This book goes down quite a distance. Love this book, in fact. So here we are. We're in the IF amplifier stage. Now, the capacitor we're looking at I don't think was in the IF amplifier stage, but it kind of is, because most of these radios share the screen supply through a number of tubes that have screen elements in them. So here's a couple diagrams, and you can see the screen, and there's a capacitor, C24 in this book. And there's the resistor. I can't remember the value in here. This resistor is a voltage dropping resistor. There's usually a fairly good current flowing from the screen, so you can drop a chunk of voltage across a resistor. Here's another diagram, same thing, C24 sitting there. So we can read up on C24. Here it is over here. And I'm going to read this down to here. So here we go. Resistor R24 drops the B voltage from the usual 250 volts available at the B plus to approximately 100 volts at which the tube screen operates. This is usually a half watt 80,000 ohm resistor. There is considerable variation in this value in different models of receivers. In general, a higher resistance will make for a lower screen voltage, and a lower value of resistance makes possible a higher screen voltage. Screen resistor R24 is sometimes omitted, and the screen voltage is taken from the midpoint of a voltage divider R15 and 16. That's just another method. Here we go. Condenser C24. You ever wonder why they call them condensers? Because they make the electricity denser. Yeah. Somehow inside the capacitor the electricity becomes more dense. That was the early view of it. Condenser C24. The bypass for the screen voltage. Bypass means it's providing a path, or a bypass path, for something to find its way down to B minus, ground, the chassis, whatever you want to say. The bypass for the screen voltage helps to filter the screen supply. Its usual value is 0.1. That's a fairly large 0.1. In this radio it's a 0.05, 400 volts. Here we are. Look, whoever had this book before me actually underlined this piece right here that we've gotten to. It's not me who underlined it. Its most important function, however, is to keep the screen of the tube at ground potential as far as the signal is concerned, since C24 offers little impedance to IF signals. This effectively shields the control grid from the plate internally in the tube and allows for stable amplification. So what is the purpose of the screen anyway? Well, just as its name suggests, it screens or blocks the view between the plate and the grid in these tubes. Now, that's the purpose of the screen. So the grid is no longer influenced by the plate. Now, how can it be influenced by the plate? Well, there's a certain amount of capacitance or apparent capacitance between the plate and the screen. There are two electrodes fairly close together. That's a capacitor right there. And the difficulty is, while you have a heavy current flowing through the tube affecting the plate, and the plate voltage is going up and down like this, the capacitance between the plate and the grid can cause some of the signal to get back on the grid. Well, once it's on the grid and affecting the grid now, the grid, feedback coming, because now the grid's going, making the plate's going, making the grid, and you got oscillations. So you stick in between them a screen, so they can't see each other through it. This effectively eliminates or reduces greatly the capacitance between, or the connection between the plate and the grid, the accidental connection or undesirable connection. But what if the screen is going up and down? Well, that's not going to help. That's going to become the same effect, basically. And screen and the plate are kind of hooked together a little bit in the radio, and I mean, they're sharing a common power supply. So if the plate stuff gets on the screen stuff, then the grid's going to see it, and it's going to go like that, and then it's going to go like this, and the whole thing's going to go. And they generally like to use the word unstable for that situation. And that's what the screen is all about. The screen is all about eliminating the plate's ability to influence the grid. So you can't let the screen do this thing. And it's at a high frequency, like maybe in the case of the IF amplifier, it'd be the IF frequency. Or maybe if it's the first tube in the radio, like I think we're dealing with here, then it's... I lost track of what I was saying. Let's continue reading here because there's more to read. Sometimes screen condenser C24 is not readily located in the receiver schematic diagram. It's kind of a weird way of saying it. Sometimes you can't find where C24 is located. This may be the case where the screens of other tubes are tied together with the IF screen for a common voltage supply, which is very typical in these radios. They use the same supply for all the plates, and then the same supply for all the screens. The screen bypass condenser will then be found at one of the other screens. As a matter of fact, in some circuits where an electrolytic filter condenser is used on the screen voltage supply, an additional paper screen bypass condenser is often found in the RF or IF screen circuit in parallel with the electrolytic condenser. And we could see when we looked at the schematic that in fact this capacitor could be considered to be in parallel with the filter capacitor in the power supply. This is to take advantage of the more effective RF filtering by the paper tubular condenser. So again, electrolytic capacitor is not so good at high frequency. And then it talks about AC/DC. You might as well read it, just another paragraph. In AC/DC receivers, operating potentials for the IF tube are approximately 90 volts for both the plate and the screen. In this case, the dropping resistor R24 is omitted, and the screen is connected directly to B+. Screen bypass condenser C24 may also be omitted, in which case its bypass function is taken over by the output filter condenser C16 in the power supply. C16 in the power supply. C16 in the power supply. Remember, I replaced the power supply capacitors with brand new capacitors. We have to assume that these are more effective at higher frequencies than the original one because these are new and the original one's old. And also it could be these just are better at higher frequency. They're just built, they're smaller, tighter, better. So it could be that having put these in, you don't actually need this other capacitor. It could be. Yeah. Anybody hear that little ding go off just now? I won something. I won an award. Okay, that's great. Now, learned a little more. For me, this is often going over territory I went over before years ago and have kind of forgotten, or it's gotten kind of foggy, or maybe I don't have a complete understanding of it. That's probably more what it is. It's coffee break time already. Yeah, after the storytelling part, we have a coffee break. Then we'll come back, we'll put the real capacitor in, even though it looks like it's not even needed in this radio. And then I think it's a trip to the grocery store for me. I think it's what's next on the store. Coffee time now. Well, have I got enough coffee? What's going on? Okay, I've got the new capacitor in. And let's operate the radio and just make sure it's still working. Put a few things away here. Today's going to be another nice, beautiful, sunny day here. Not too hot, 22 or 23 or something like that. But like I said before, in another day or two, we're going to be steaming. Well, steaming by our standards, which means 32 degrees plus high humidity. So we would call it feeling like, 38 or 40 or something like that. Okay. Here we go. Don't expect any change whatsoever because I discovered before not even having this capacitor in. The radio works fine, probably because of these capacitors here. Well, it works as good as it did. I shouldn't say it works fine. So I think that's 590. Yeah, 640 seems to have disappeared. Okay, enough of that. Enough of that. It's working pretty much the same as it was. The not being able to pick up a station had to do with just the angle of the antenna and the relative strengths of noises being received and that kind of stuff. So there we go. One more capacitor done. So tomorrow we'll pick another one. We'll do the same kind of thing. We'll consider operating the set with the capacitor missing and see what it does. Okay. Well, thanks a lot for watching. I'm off to Costco now to do grocery shopping and live my life outside of the shop here. Have a great day, and see you tomorrow.